Welcome to this presentation on core functions of file management systems, presented by deeplearn. Now that we have established a foundational understanding of file management systems, let's examine their core functions. At the heart of any file management system is a set of fundamental operations that users must perform on files. These include creating new files, deleting unnecessary ones, opening and closing files, and reading from or writing to them. Think of a file management system as a library. When you create a new document, it's akin to adding a new book to the library. Deleting a file is like removing a book that's no longer needed, while opening a file is similar to checking out a book for reading. Each operation is designed to facilitate user interaction with the file system seamlessly. Each file also maintains a set of attributes, metadata that provides essential information about the file. This might include the file's name, size, type, creation date, and permissions. Such attributes are crucial for effective file management, allowing the system to enforce access controls and ensure data integrity. Moreover, a well-designed file management system must meet the diverse needs of users. For instance, users should be able to manage their access to files, enabling them to control who can view or edit their documents. This is particularly important in collaborative environments where the sharing of files needs to be both secure and flexible. As we continue this discussion, consider how effectively these core functions enable users to interact with and manage their data. What challenges do you think arise in complex systems with many users accessing shared files? As we delve further into file management systems, it's essential to understand the terminology associated with file structures. The terms field, record, file, and database are foundational concepts in data organization. A field represents the most basic element of data, containing a single value. For example, in a contact list, a field could represent a person's phone number or email address. Fields can vary in length, making them flexible for different types of data. Moving up a level, a record is a collection of related fields that can be treated as a single unit. Imagine a record as a row in a spreadsheet, where each field represents a column of data. This structuring allows us to manage and retrieve related information efficiently. When multiple records come together, they form a file. A file serves as a collection of similar records, enabling applications to access related data as a single entity. For instance, in a customer database, each customer could be represented by a record within a file, encompassing all their details: name, address, and transaction history. Finally, when we accumulate multiple files, we achieve a database, which is designed for use by various applications, reflecting the relationships among different data elements. Understanding these terms is crucial for grasping how data is organized and accessed in file systems. As we consider these definitions, reflect on how they relate to the applications you use every day. How do you think the organization of data impacts the efficiency of those applications? Having established a clear understanding of file structures, we now turn our attention to the essential attributes of file management systems that ensure functionality and performance. One of the most critical attributes is data validity. This means that the system must guarantee the integrity and correctness of the data stored within files. Imagine working with a financial application. If the data is corrupted or invalid, it could lead to erroneous calculations and significant financial repercussions. Thus, maintaining data validity is paramount. Another essential attribute is performance optimization. File management systems are responsible for enhancing the speed and efficiency of data access. This involves various strategies, such as indexing files for quicker searches or caching frequently accessed data. For example, when you access a frequently used document, the system may retrieve it from a cache rather than the slower secondary storage, significantly improving response times. Additionally, I/O support is crucial for interactions across different storage devices. A robust file management system needs to facilitate seamless data transfer between the operating system and various storage mediums, whether they be hard drives, SSDs, or even cloud storage. This versatility ensures that users can access their data regardless of its physical location. As we explore these attributes, consider the implications of inadequate data validity or slow performance. What challenges do you foresee in environments where multiple users interact with a file management system concurrently? In our exploration of file management systems, we must address the various file organization types available. Each type serves a specific purpose and is optimized for different access needs. The most common structures include the pile, sequential file, indexed file, and direct or hashed file. The pile is the simplest form of file organization, where data is collected in the order it arrives. This structure works well for scenarios where data is ingested rapidly but poses challenges for retrieval, as it requires exhaustive searching. Sequential files, on the other hand, maintain a fixed format for records, enabling efficient access when data is processed in order. This is particularly useful in batch applications, such as payroll systems, where entries are processed sequentially. Index sequential files enhance efficiency by adding an index to support random access. By using indexing, the time required to locate a specific record is significantly reduced, making this structure advantageous for applications that require quick lookups. Indexed files rely exclusively on indexes for record access. They are particularly effective in applications like airline reservation systems, where rapid access to information is critical. Lastly, direct or hashed files allow for immediate access to records based on a known address. This structure is optimal for applications demanding extremely rapid access, such as pricing tables or directories. As we consider these various file organization types, think about the applications you use in your daily life. How might the choice of file organization impact the performance and efficiency of those applications? Now, let us explore the role of access methods within file systems. Access methods are critical as they represent the closest level of the file system to the user. They provide standard interfaces that facilitate how applications interact with file systems and the devices that hold data. Consider how you interact with a file through a word processor. The access method allows you to open, save, and edit documents without needing to understand the underlying complexities of the file system. This abstraction simplifies user interactions, making technology more accessible to a broader audience. Different access methods cater to various file structures and ways of accessing and processing data. For instance, a random access method would be suitable for indexed files, allowing users to jump directly to a specific record, while a sequential access method would be more appropriate for files organized sequentially, where data is processed in a linear fashion. As we reflect on access methods, consider this. How does the choice of access method impact your experience as a user? Have you ever encountered a system where the access method impeded your ability to retrieve or manipulate data efficiently? As we progress, it's crucial to discuss the challenges associated with file sharing and access rights. In collaborative environments, allowing multiple users to share files introduces complexities that must be managed effectively. Access rights are fundamental in defining what users can and cannot do with a file. This includes permissions for reading, writing, executing, and even deleting files. Imagine a scenario where a team collaborates on a project document. Each team member might need different access levels to contribute effectively while ensuring that sensitive information remains protected. Simultaneous access by multiple users adds another layer of complexity. File management systems must implement strategies to manage concurrent access, ensuring data integrity and preventing conflicts. For example, when two users attempt to edit the same document at the same time, the system must reconcile those changes to avoid data loss. Security remains a paramount concern in shared environments. Robust file management systems must enforce strict access controls and audit logs to track who accessed what data and when. This is particularly important in industries like healthcare or finance, where sensitive information must be safeguarded against unauthorized access. Reflecting on these challenges, consider, how can organizations strike a balance between collaboration and security in their file management practices? What strategies might they employ to mitigate the risks associated with file sharing? As we conclude our exploration of file management systems, let's recap their importance in modern computing. These systems serve as the backbone of how we store, access, and manage data, impacting everything from personal computing to enterprise applications. In real-world contexts, file management systems are utilized across various industries. For instance, in healthcare, patient records are meticulously managed through robust file systems to ensure data integrity and compliance with regulations. Similarly, in finance, accurate file management is essential for maintaining transaction records and protecting sensitive customer information. Looking to the future, the evolving needs for data management in a digital age present both challenges and opportunities. With the rise of big data, cloud computing, and artificial intelligence, the capabilities of file management systems must adapt to handle vast amounts of data securely and efficiently. As we move forward, consider how advancements in file management will shape the way organizations operate. What innovations do you envision in data management systems, and how might they transform our interactions with technology? This presentation framework utilizes the provided text to create a structured, logical series of learning experiences for university students. The narrative scripts are designed to engage students and encourage critical thinking, fostering a deeper understanding of file management systems. Thank you for watching this presentation.